Hi, the title of today's lecture is Early Genus Homo, so early Homo. One of the main questions we need to ask is, how do we define the genus Homo? In other words, what does it take to be human? Sir Arthur Keith argued that brain size is the critical and defining feature of humans. He argued that the cerebral Rubicon of 700 to 800 cc's marks the boundary for someone being human. How did he come up with this value of any specimen that has a cranial capacity of 700 to 800 cc's or greater must be human? Well, because he argued it was halfway between the largest gorillas and modern humans. And on that basis, must be humans. Not gorilla, but bigger than a gorilla and less than the average for modern humans. This is referred to as the cerebral Rubicon of human brain size. Most paleoanthropologists are not necessarily comfortable with using Sir Arthur Keith's cerebral Rubicon for determining whether or not a species was a member of the genus Homo or not. Rather, they'd like to use cladistic characteristics. In particular, there are 4 synapomorphies that predominantly define the genus Homo. A synapomorphy is a trait that is shared by 2 or more taxa and presumably by their most recent common ancestor, but no other more distant ancestors. The 4 synapomorphies that are known to define the genus Homo are increased cranial vault thickness, reduced postorbital constriction, an anteriorly positioned foramen magnum, and reduced facial prognathism. The first fossils that were actually attributed to the genus Homo were first described by Louis Leakey in 1964 at Olduvai Gorge in Tanzania in East Africa. The location is indicated by a red dot on this big map of the African continent. The specimens were dated to a time period between 2 to 1.7 million years ago. I want to point out that this is contemporaneous with the robust Australopithecines that we spoke about previously. The type specimen for Homo habilis is referred to as OH7. Because it was found at is an Olduvai hominid, and it was the 7th hominid specimen found at Olduvai Gorge. The teeth of Homo habilis in general are much smaller than those of the Australopithecines. Its cranial capacity is between 642 to 723 cc's. You average it out, it's around 700, right in the ballpark of the cerebral Rubicon of Sir Arthur Keith. Basically, the important point here is that its cranial capacity is substantially larger than the Australopithecines, who are all within the 400 cc range. Raymond Dart, remember him? He was the guy that found the first Australopithecine. Well, he was the one that suggested to Louis Leakey that he should name Homo habilis habilis, because habilis in Latin means handy, skillful, and able. And Raymond Dart believed that these specimens should be referred to as habilis because they were found in association with the first known stone tools called Oldowan stone tools, which I'll talk about moments ago. Remember, this is in 1964. Remember I said Australopithecus garhi is the first known stone tool user. This was in 64, and these are the first time we found stone tools with any hominid. So what are some of the morphological characteristics of Homo habilis? Well, the cranium, the skull, is much more gracile. There's not a lot of crusting due to much reduced muscle action. The cranial capacity averages 700 cc's. Most importantly, and this is very interesting, Homo habilis is believed to possess what's called Broca's area. Broca's area is located in the middle of the left cerebral cortex of your brain, and this area of the brain is exceptionally important for speech development. Without this characteristic, without Broca's area, speech probably wouldn't develop. So some people have suggested that they're starting to develop the neural networks necessary for speech. Others argue that Homo habilis probably had speech. I think that's highly unlikely, but I do agree that they are developing the neural networks necessary for the development of speech. We also see that they have a much smaller gracile mandible. What about the postcrania? The postcrania are largely unknown. That is, they're not often found with diagnostic cranial material. So because these guys were contemporaneous with the robust Australopithecines, it's hard to know if the postcrania were similar to the contemporary robust Australopithecines, and so it's very difficult to decide which species to assign the postcrania to. If you find an arm bone, how do you know it's Homo habilis, or how do you know if it's a robust Australopithecine? For example, one hominid specimen is called OH8. It's a foot, and it's very modern looking. So on that basis, it was automatically assigned to Homo habilis. OH17, they're hand bones, and they have curved phalanges, which is a primitive trait, and therefore they were assigned to the robust Australopithecines. See what the problem is? Making assumptions based on what you assume the trajectory for evolution is. Now, I said that these Homo habilis specimens were found in association with the earliest known stone tools. These stone tools are referred to as the Oldowan tool industry. The Oldowan tool industry occurred from 2.5 to 1.5 million years ago, and to as recently as 0.25 million years, or 250,000 years ago, in Asia. It is the only known tool industry in Asia. Homo habilis and possibly Paranthropus boisei, one of the robust Australopithecines, were probably known to have created these stone tools. All East and South African sites with Oldowan tools contain the remains of both Homo and Australopithecine species. So it's very unclear who actually created them or who made them. So notice that these are very, very primitive. They're very crude. And it would take a lot. You'd have to be really trained to recognize that these, in fact, are stone tools and were purposefully created by humans versus something that was created by nature. Historically, a lot of specimens were lumped into the taxon Homo habilis, despite the tremendous variation that existed. Some might say that they were using Homo habilis kind of like as a garbage can taxon. And one of the things that this resulted in was a tremendous amount of variation within the genus Homo sapiens, Homo habilis. Specimens that were not Australopithecines, that were not Homo erectus, they were called Homo habilis, regardless of how much they varied from the type specimen of Homo habilis OH7. In the mid-1980s, paleoanthropologists began to acknowledge that they'd been using Homo habilis as a garbage can taxon, and they recognized that it was time to change. So the first thing they needed to do was to identify how they thought about human evolution during this time period. Well, historically, they thought that the genus Homo was divided into 3 time-successive chronospecies: Homo habilis, which gave rise to Homo erectus, and Homo erectus, which gave rise to Homo habilis. I said that backwards, so let me redo it, because I wrote it backwards on my slide. Homo habilis gave rise to Homo erectus, and Homo erectus gave rise to Homo sapiens, so it's going down, okay? This type of trajectory of you have time-successive species reflects the view that the human lineage, the genus Homo, represents a single anagenic lineage where you're having the gradual accumulation of changes that lead from ancestor to descendant. So Homo habilis over time accumulated changes and evolved into Homo erectus. Homo erectus over time accumulated changes and evolved into Homo sapiens. The problem with this anagenic lineage is that it underestimates the number of species of Homo that existed at any one time in the Pleistocene. In the 1990s, paleoanthropologists started to analyze the variation within the genus, within the species Homo sapiens. And the thing they found was that the amount of variation present in Homo habilis was more than 3 times the variation that is found in modern human populations or living chimp populations or gorilla populations. Think about that. More than 3 times the variation in modern human populations was being included in the genus Homo habilis. So basically it indicated that it was time to sort out the different characteristics and divide Homo habilis into its component parts. So what paleoanthropologists did at this time was they divided the catch-all Homo habilis into 3 species: Homo habilis, Homo ergaster, and Homo rudolfensis. And the reason I feel it necessary to go into this is because not all textbooks have kept up with these taxonomic changes. And so to make it clearer for you, I want to make sure you understand why some of these taxonomic changes have occurred. So let's go and talk about how we actually can distinguish habilis from ergaster and ergaster from rudolfensis. So this is just a depiction of an anagenic lineage where the Australopithecines gave rise to habilis, which gave rise to erectus, which gave rise to Neanderthals, which eventually gave rise to modern humans. This is what we're saying is wrong. It's not one species giving rise to another. What we're seeing here is that you're having multiple species at any one time period simultaneously. So like right here, there are 3 different species. Right here, there are 3 different species occurring during the same time period. This is much more representative of how human evolution probably occurred. So the new habilis generally is defined by having an Australopithecine-like postcrania, and by that I mean it has a very primitive postcrania, ape-like features in its postcrania. But its skull has more modern chewing. Look how small these teeth are. Teeth look very, very modern looking. Cranial capacities averaging 700 cc's. The skull is known as 1813 and the mandible is OH7, which was the type specimen. And then we have Homo rudolfensis, the second specimen, the second species that habilis was broken down into. Homo rudolfensis superficially resembles the robust Australopithecines in that it has very primitive chewing. Okay, it has a modern, so you see a lot of attachments, bony attachments for chewing muscles throughout its skull. So like right here, you see all these extra bones for attachment of chewing. It has a very modern postcrania, so its locomotor style was very, very modern, and its cranial capacity is increasing substantially, 800 cc's, twice that of the early ones. This specimen is known as ER 1470, East Rudolph 1470. This is Homo ergaster, the third species that Homo habilis was broken down into. Homo ergaster is often referred to as the African Homo erectus. It has very modern teeth and modern chewing apparatus, so its cranium is very, very modern, but it also has modern postcranial skeleton, much more so than Homo habilis. Its cranial capacity is averaging 1100 cc, rapidly catching up to the 1400 cc's of modern humans. There's a very important specimen of Homo ergaster that I want to mention, and it is known as the Narikatomi boy. The specimen is dated to 1.6 million years ago, and it was found in Kenya. It represents a boy of about 12 years old. This is based on both the dental eruption patterns and the closure of the sutures. There's really no way to actually tell its sex because it's a juvenile, but most people have referred to it as a boy because of how tall it is. It's about 5'4", and this is slightly taller than a modern boy or girl of the same age, and it's expected that this individual probably would have reached an adult height of 6 feet. Its cranial capacity, however, was only 900 cc's. This is a figure of the Narikatomi boy, WT, West Turkana, 15,000. Isn't he cute? He has this big broad smile, and we have so much of his skeleton, and it looks tremendously modern in appearance. There are 2 very important differences between Homo ergaster and modern Homo sapiens that I want to mention. One noticeable difference involves the size of the opening for the of the vertebra where the spinal cord passes through. This is known as the neural canal. So the hole where this is your one of your vertebra, and your spinal cord goes through here, and this represents your neural canal. And the neural canal is smaller in Homo ergaster than in modern humans, especially in the mid-back and in the neck region. And it's been suggested by some that Homo ergaster had less control over breathing than modern humans. And why would that matter? Well, you need to be able to breathe and talk simultaneously, and this suggests that Homo ergaster did not have the modern capacity for speech, despite the presence of Broca's area that we first see with Homo habilis. So a very important anatomical trait that we're seeing a difference in. Second major trait distinguishing Homo ergaster from modern Homo sapiens is that males were only 20% larger than females. Modern humans, males are only 15% larger than females. That contrasts sharply with all the previous hominids that we've talked about. The Australopithecine males were 50% larger than females. This suggests that there may have been less male-male competition for access to females. And this is suggestive that there may have been a shift towards a monogamous mating system with substantial parental investment or paternal investment in offspring, because less dimorphism is often characterized by reduction in male-male competition for access to females. So that's a very interesting behavioral interpretation that we can make based on the amount of dimorphism within this species. There was another very, very interesting specimen of Homo ergaster that was found that bears discussion, and it's referred to as KNM ER 1808. KNM, Kenya National Museum, ER, East Rudolph, 1808. It's an interesting specimen that was found in Kubifora in East Africa. This individual represents the most complete Homo ergaster specimen ever found. It's believed to be a female based on pelvic comparisons with ER 3228, which is a male, and an OH 28 female. And the sex was based on these modern human criteria, which we talk about in the lab. The most intriguing aspect of this specimen is that it demonstrates a striking pathology and abnormality of the bone. It has periostosis of long bone diaphyses, up to 7 millimeters thick. This means that there are deposits of coarse woven bone on top of the bone, up to 7 millimeters thick in places. So on top of the normal bone, there is additional bone being deposited. And it's really rough, coarse woven bone. And it's been suggested that the dense mineralization of this specimen is why it has preserved as well as it has. Alan Walker and others have suggested that this individual had chronic hypervitaminosis A. Chronic hypervitaminosis A. Chronic hypervitaminosis A is associated with peeling skin, vomiting, diarrhea, headache, convulsions, night blindness, and even death. But it's rarely seen in modern adults. Since 1951, there have only been 17 cases in adults. However, there have been numerous cases in infants and toddlers who take too many vitamins. How many of you have ever consumed Flintstone vitamins while you were growing up and found that they taste good, so you start eating more and more and more of them? Or nowadays it's Vitafusion gummies and you eat a lot of them. Well, you can develop hypervitamin. Imagine like a toddler finding a bottle of them and thinking they're candy. And so they eat them all, and parents don't know. They think that, hey, they're vitamins, they've got to be healthy. And as a result, we commonly see it in infants and toddlers, but not in adults. So the question is, if hypervitaminosis A is the result of this pathological bone deformation, how did Homo ergaster ingest so much vitamin A? What would have caused that? Well, it's been suggested that early polar explorers are also known to have developed hypervitaminosis following the consumption of bear, seal, and dog liver. In 1942, it was recognized that vitamin A was the toxic component of dog, bear, and dog, seal, and polar bear liver. And this suggests that Homo ergaster may have been eating raw carnivore liver, which is very high in vitamin A. And so what's the implication of this? It suggests that there may have been a dietary shift towards increased meat eating by Homo ergaster, as well as a learning curve on which parts of the carcasses were poisonous when consumed in large quantities. So very interesting specimen, and giving us insight into when the behavioral change for meat eating may have arisen. So this is Homo ergaster. You can see big brow ridges, but much reduced. We see the developments of foreheads, so forward movement of the brain, okay, V-shaped mandible, worn teeth. Homo ergaster, much like Homo habilis, continued to use Oldowan stone tools, but they also began to construct much more complex tools. These new tools are referred to as Acheulean. So before we had Oldowan stone tools, now we're talking about the Acheulean stone tools. The Acheulean tool industry occurred from 1.4 to 0.3 million years ago in Africa, Europe, and the Middle East. Remember, there's only one tool industry in Asia, and that is the Oldowan. So these tools are generally referred to as bifaces, and the most common is the hand axe. Asian Homo erectus fossils, once again, are only found with Oldowan tools. This pattern was noticed by Movius in the 1940s, and there's a line called the Movius line which separates Asia from Africa and Europe in terms of the distribution of stone tools. Most scientists relate the absence of hand axes in Asia to differences in raw material availability. In Asia, they have an abundance of bamboo, and bamboo is much easier to modify than is stone, which is a relatively difficult raw material to work with. And so that's one of the reasons that that's maybe the reason we're seeing this difference in its geographic distribution. This is an Acheulean hand axe. This actually looks like a stone tool, unlike those Oldowan tools, okay? And here are bamboo tools that have been created. So you can see bamboo is a lot easier to create than an Acheulean stone tools. Homo ergaster was the first hominid to extend its range beyond the tropics. It moved into colder regions of China, moved into Germany, and it moved during long, cold glacial periods. In order for Homo ergaster to survive these new environments, they needed to have some way of dealing with this cold temperature, dealing with these cold, temperate winters. To survive the rigors of cold, Homo ergaster must have had a new way of dealing with this cold environment. Talk about fire is almost a prerequisite for the move Homo ergaster must have made into these temperate regions. Up until 1995, the most accepted date for the first man-made fires was 0.5 million years ago, 500,000 years ago at Chaokudian in China, and this was for Homo erectus. It is now believed that the archaeological evidence from 1995 represents a natural-made fire, not a man-made fire. And that it was actually bat guano that exploded and caused the burning of the materials within the cave. There's no evidence in Chaokudian that early hominids, neither Australopithecus or early Homo, controlled fire. It's possible that charcoal hasn't been preserved at these open-air sites, but there's no evidence for that Australopithecus or Homo habilis had any controlled fire. archaeologist Randy Bellomo recently conducted experiments in East Africa to test whether the baked earth at Kubi Fora from 1.6 million years ago, during the time period of Homo ergaster, represented a campfire made by man, a tree stump fire, that would be a natural made fire, or a grass fire, another form of natural made fires very common in East Africa. So what he did was he set tree stumps on fire, set grass fires, and set campfires at numerous localities within East Africa, and he then examined the remains. What would an archaeologist find after left over from these types of fires? And he found some very interesting results. The first is that the soil under the campfires reached a much higher temperature than soil under the grass fire or under the tree stump fire. This higher temperature produced by a campfire produced two distinctive characteristics. The first is a bowl-shaped layer of highly oxidized soil, and secondly, the bowl-shaped layer of oxidized soil was also highly magnetized. He found that the Kubi Fora features after 1.6 million years ago were in fact hominid-made fires. So Homo ergaster after 1.6 million years ago was in fact making fire. And that is how they managed to extend their range out of the tropics and into more temperate regions. So these are some of the residues that he found. Okay, now we move on to Homo erectus. Homo erectus is also known as Java man. They are found in Asia, and specifically in Java within Indonesia, by Eugene Dubois. He was an anatomy professor at the University of Amsterdam, and in 1891 at a site called Trinil, Dubois found a skull cap and a femur. And Dubois was convinced that this represented an erect, ape-like transitional form between apes and humans. In 1866, Ernest Haeckel proposed the generic name Pithecanthropus for the missing link. So Dubois referred to this specimen as Pithecanthropus erectus. This shouldn't say 1981, this should say 1881. I apologize. So Dubois called his specimen Pithecanthropus erectus, or the erect ape man. As I said, it's also known as Java man. In 1927, another paleontologist by the name of Davidson Black, who is from Canada, began excavations at Locality 1 in Chalcudian Cave. This is commonly referred to as Dragon Bone Hill. The dragon teeth were actually Homo erectus teeth. He died in 1933 and was succeeded by Franz Weidenreich. The excavations continued until 1937. They had over 40 plus individuals from Chalcudian Cave, but these fossils, sadly, have been lost. In 1937, Japan occupied northern China. The Chinese shipped the fossils to the U.S., care of the U.S. Marines. The Marines, unfortunately, were interned by the Japanese on the 7th of December in 1941. So we have no idea where those fossils went or what happened to them. The only positive note of this is that Weidenreich had made plastic replicas of all 40 of those specimens. These are housed at the American Museum of Natural History in New York City. In between 1936 and 1941, Koningswald was also working in Java, but he was working at two different sites. One's called Mojokerta, another called Sangiran, and he found some fossils very similar to that of Dubois. The biggest problem with much of the Homo erectus material concerns the dating. Most Homo erectus sites are places where water is flowing or carnivores have accumulated the remains. Most importantly, most of the specimens of Homo erectus have been discovered by non-specialists who removed the specimens from context before a paleoanthropologist has been able to record its exact provenance. So what can I tell you about Homo erectus, given the loss of the fossils and the fact that dating is so poor and that so many of the specimens have been found by non-specialists? Well, the best dates at present for erectus are 1.2 million to 400,000 years ago. The cranial capacity is 900 cc's. One of the most distinct features of Homo erectus is that it's the first specimen to have a nasal spine, this bone right here in your nose that pushes your nose outward. It's the first species to have it. All the other previous hominids do not have a nasal spine. Homo erectus has shovel-shaped incisors. It has very, very thick skull bones. It has no chin. You're not going to see the chin appear until modern Homo sapiens. It has really big, pronounced brow ridges, a receding forehead, a sagittal keel, which is a thickening of bone along the sagittal plane of the skull. The greatest breadth of the skull is near the base. We see a thickening of bone at bregma, and once again, the projecting nasal aperture. Couple additional features. They have pronounced alveolar prognathism, so we're seeing the prognathism. We see really large cheek teeth relative to modern people. We see a diastema between the upper canine and the lateral incisor, especially in the Javan specimens. And the third molar, which would be your wisdom tooth, would be smaller than your second molar. And some have even suggested that the crudes are actually Homo erectus. What about the postcrania of Homo erectus? It is mainly known from both the femur and the pelvis. The pelvis has a thick buttress, a pillar of cortical bone arising vertically from the acetabulum. That's identified right here. The femur has thick external cortical bone, narrow medullary cavities, and pronounced muscle markings. The reduced medullary cavity is very unusual among animals. Only manatees, dugongs, and humpback whales are known to have no medullary cavity, and Homo erectus barely has a medullary cavity. It's very, very reduced. The muscle markings on the upper arms suggest tremendous upper body strength. The limbs were very, very strong, and this indicates a high level of recurrent stress and extended periods of heightened muscular exertion. The femoral shaft has greater foraft compression, meaning that the femur is actually oval in shape instead of round. Just as another very odd feature of Homo erectus is that at Chalcodien, many fossil skulls lack faces. It's been suggested that Homo erectus may have removed the face to cannibalize the brain. It's also possible that scavengers affected their remains. It's hard to know at present. This is one of the specimens that was found by Dubois. You can see this big, massive brow ridge. This is Peking Man. Once again, big brow ridge. You can see the beginning of the alveolar prognathism progression.